In this video, I'm going to talk about Unit 6, Day 20, Lesson 10b, Graphs of Functions in Standard and Factored Form. The focus question for this lesson is what properties about the graphs of quadratic expressions do the standard and factored forms reveal? And so we're really focusing on the x-intercepts and the y-intercepts and where we see those in both standard and factored form. So that's going to be the focus, and that's what students are going to look for today. In this video, I'm going to show you how you can execute this lesson using the Desmos platform and utilize the annotations feature to really reinforce student understanding of this concept. In another video, I'll talk about how to actually build lessons on Desmos. This is more about the execution. So I created a lesson on Desmos that mirrors the slides, and that link, the link for this lesson will be shared in the caption of the video. So the lesson opens up with notice and wondering. Students are not asked to annotate here. They're simply asked to just notice and wonder anything about the standard and factored form expressions and the graph itself. So students might point out a couple of key things, and you just want to start start modeling how to annotate on the graph. So on here I have I'm going to change the color to red, and I'm going to show, okay, some students might say, I noticed the y-intercept is 0, 3. And I'm going to actually go next to it and type that on. And I might even add on, oops, that's my y-intercept. And so it's a good practice for students to just be able to go ahead and annotate on the graph. Students might also point out, I'm going to choose a different color, green, the x-intercepts. And I'm going to plot both of those x-intercepts in the same color. And I'm going to label them x-intercepts. And it's a little bit, I wonder, can I make it bolder? No, but it's a little bit light, but that's okay. And then I'm going to just label these points. It's just giving students a chance to practice. So students would have noticed these two things. -3, 0. Now, some students might also point out they notice that the y-intercept is 0, 3. They also notice that there's a 3 in 2 of the equations. So again, you can write on the screen and say, we're noticing, is this the y-intercept? I don't know. We can come back to that. Students also might notice that -1 is here, and that's a +1. Is there a connection there? So I might use the same color green, box that off, and say, is the opposite of this the y-intercept? Sorry, the x-intercept. Right, so I'm just jotting down the noticings in a visual way, trying to start to build the connection using color. I probably could have used red here to really show, because we're talking about the y-intercept. And we don't know. And somebody else might say, I noticed that the 3 is here and that the x-intercept is a -3, so is there a connection there? Okay. And so I'm using annotations to just start to give students an idea of how to think about the connections. I'm using color, and students are able to write directly on here as well. Okay? So now we went over this one, and you could encourage students to go ahead and make those annotations as you're making them on their own Desmos. And so students are then invited to use the next few slides to identify, they're asked, identify the x-intercepts and the y-intercepts. And so in this case, students will work through slide 2, slide 3, 4, 5, and then on slide 6, they're asked to answer these questions. What do you notice about the x-intercepts, the y-intercept, and then and then numbers in the expressions defining each function. Make a couple of observations, annotate the connections. So students may have been annotating on the previous slides, they may not have been, and that's okay. And they come to here and we really want them to start to see the connection. So we want to push them to annotate. So they'll do this on their own or in groups. And then when you're coming back together for the discussion, you have the option to A, feature someone's annotations if you see some really beautiful annotations. And if you do find annotations that make sense, it is smart to have someone share their screen and feature their annotations so students can see that there's not only one right way to do it. But look for people who are using color to make those connections. And if somebody hasn't done that yet, because you haven't been doing annotations often in class, you can model the annotations by reading off the responses. So somebody might have said, I noticed that the Y-intercept is in the graph at 0, 4. And I noticed that the Y-intercept is also in the standard form of the equation as the C term, so I want to use green, as the last term. So I'm using green, I'm using color to show that connection. And then at this point, you might encourage everyone to annotate on their screen. And so that's the Y-intercept there, and we see the Y-intercept here at 0, 4. Okay, and we have an eraser feature too. And then somebody else might point out there's only one X-intercept. That one X-intercept is at -2, 0. And we see that X-intercept right here happening at -2. So we might have students right above it as -2, the opposite of that. Okay, and so once students have been able to kind of make these connections and annotate on their graph, the really key idea is we want them to come away with saying, okay, the Y-intercept happens in standard form. Let's use a different color. This is standard form. Standard form gives us the Y-intercept in the C term. And then factored form, is the X-intercept, and it's the opposite of the, it depends on what you're calling these, but we can call them the H and K terms. Okay, but you might call them something else, and that's okay, depending on how you've talked about it. You might also just say, if you haven't got that far into like looking at it as an expression with all variables, you might just say it's the opposite of the terms, whatever's being added or subtracted from X, right? So they might have their own wording for that, and that's okay. And so you're able to kind of use, if you notice, you're able to use color to really show those connections and give students that visual. Depending on how much time you have, you might then say, okay, go back and annotate the connections between the other expressions within the slides prior to slide 6. Okay, and then when you look at student work, you'll be able to see the annotations they're making and give them feedback. Too much color can be overwhelming, so you really want to try to strategize with what color you're using. And then you have the synthesis questions in here for students to access. Okay? So in summary, annotations are a really great tool you can use to solidify student understanding and make connections between multiple representations.